academician, visionary administrator, and highly respected personality in the field of microprocessor technology and application, Professor Dr. B.K. Singh, sir. B.K. Singh, sir, has made remarkable contributions in the domain of electronics and communication engineering through its outstanding academic excellence, research, and leadership. He served as a professor in the Department of Electronics and Communication Engineering at the prestigious Bipin Tripathi Kumar Institute of Technology, Dwarhat, where he inspired countless students and scholars with his deep knowledge and dedication towards technical education. His glorious journey of academic leadership further reached greater heights, and he served as the Honorable Vice Chancellor of Veer Madhav Singh Bhandari, Uttarakhand Technical University, guiding this university with vision, innovation, and commitment towards the quality technical education and research. Presently, he is serving as the director of renowned Birla Institute of Applied Sciences, Bhimtal, District Nainital, where he continues to shape the future of science, technology, and innovation with his dynamic leadership and vast experience. Sir is widely recognized for his expertise in microprocessor technology and application, and his valuable guidance has always been source of inspiration for students, researchers, academians, and professionals. On behalf of all of us, I extend a heartfelt welcome to our esteemed guest, Professor Dr. B.K. Singh, sir. Sir, we are truly honored by your gracious presence among us. Now, I would like to invite Dr. Sandeep Negi, sir, to formally welcome our esteemed guest. Sir, please.
Good evening to all. आदरणीय प्रोफेसर वीके सिंह सर का आइकन प्रेजेंटेशन सीरीज पर हार्दिक स्वागत। प्रोफेसर सिंह सर की जानकारी हेतु मैं यहाँ बताना चाहूंगा कि इस मंच का उद्देश्य तकनीकी के क्षेत्र में इंटरेस्ट रखने वाले स्टूडेंट्स को प्रेजेंटेशन का मौका देने के साथ साथ तकनीकी जानकारियां संग्रहण तथा प्रसारण तक विस्तारित होता जा रहा है। स्पष्ट उद्देश्य यह है कि तकनीकी जानकारी प्राप्त करना चाह रहे रिमोट लोकेशंस के स्टूडेंट्स को भी आधुनिक तकनीकी से रूबरू होने का मौका मिले। अब मैं प्रोफेसर वीके सिंह सर को उनके द्वारा आइकन के मार्गदर्शन हेतु निवेदन करना चाहूंगा। प्रोफेसर वीके सिंह सर, सर आदरणीय।
गुड इवनिंग। ऑडिबल ना? सुन पा रहे हैं मेरा?
यस सर।
हाँ सर, ऑडिबल हो।
ठीक है, ठीक है। ओके। गुड इवनिंग एंड वार्म वेलकम टू एवरीबॉडी who are connected in this session. Probably today the last session of the durations of the program. It has been arranged from 26th to 30th. So first of all, I am very much thankful to Dr. Sandeep Negi ji, Anushka madam, and his team for welcoming me and giving me the opportunity to say my few words in this session. I would like to also appreciate the efforts of Veer Madhav Singh Bhandari Uttarakhand Technical University for taking the initiatives in artificial intelligence knowledge sharing session. And the session was really very long, from 26 to 30th, approximately 5 days the session has been conducted. And as Dr. Sandeep Negi ji informed me, not only the students from this university, the students from the schools or different universities have also joined and taking the advantage of this session. So really appreciation for the university and the whole team for organizing these types of function. From last 1 year, I am also having the feelings that the university has organized so many programs. just to motivate our students. And considering the different projects, our students has also been inspired um, by the different activities of the university, and all the institutions are really participating with good wills. So appreciation for the university for this point of view. Definitely this session will sensitize the young mind of the university. I think university affiliating colleges have also been sensitized, because when you are organizing any program, university organizing any program, the message go to the colleges, and the colleges itself organize the program for success of this program in the institute. Really, this session has really sensitized the young minds and the institute as well. The students have got opportunity to think beyond the textbook, and they may be able to explore the possibility of unlimited possibilities of artificial intelligence, machine learning and deep learning, and many more, the technology which are coming up. The participants have been asked to give the presentation probably in energy forecasting, fuzzy logic and control, research and innovations. These are the area students have been asked to give the presentation. Definitely it will give the exposure to all the students in this area. As far as the artificial intelligence, machine learning and deep learning is concerned, I think there will be no field in the future in which the artificial intelligence or this emerging technology cannot be used. Everywhere it will be used. There is a bright future of this emerging technology. We used to tell the proverb that science and technology can't be imagined about the mathematics. So in future there will be proverb that comfort life without artificial intelligence cannot be imagined. So with this commitment, the student and every stakeholder should encourage all this artificial intelligence implementation and exploring all these things. The era of artificial intelligence has just begun. I think it will go for longer period. It will go for longer period. As far as the vision of Honorable Prime Minister is concerned, uh, he wants that India should be superpower by 2047. And many times he told that आने वाले समय में उत्तराखंड का ही समय होगा. जब इन्होंने ये बात कही है, तो हम उत्तराखंड के जितने भी विद्यार्थी हैं या जो यहाँ पढ़ रहे हैं, उनके प्राइम मिनिस्टर से इस कमिटमेंट को पूरा करना हमारा अधिकार बनता है, हमारा कर्तव्य बनता है. तो इसको हम इसी उद्देश्य से लें, इस बात को पूरा करना है. सुपर पावर जहाँ की बात है, तो अगर हम पहले एनालाइज करें, जितनी भी डेवलप्ड कंट्री हैं, वो सुपर पावर क्यों बने, उनका मेजरमेंट करने का तरीका क्या है. तो व्हेन यू आर एनालाइजिंग ऑन द बेसिस ऑफ द per capita energy utilization, so Canada is at the top most. After that USA is there. After that I think Australia, Japan, Germany, ये जापान के बाद फ्रांस होगा, China, and India is coming at 170th position. It means there is a huge gap. We have to fill this. So here the role of artificial intelligence comes. You have to estimate if you want to be the superpower by 2047 through the artificial intelligence or emerging technology, we have to estimate how much energy per capita we have to develop, we have to generate. And one more challenge this times we are finding that not only you have to develop the energy, you have to develop the energy with the some challenges. You have to also care the pollutions. It means harvesting of energy through the renewable sources of energy. This will be very important. So this is one field of challenges. But when you are doing the something about the artificial, the first question comes in mind: from where we can start? These big questions. So I would like to suggest that as a project in the final year, as a project in the third year, as a project, you can start from the first, second year also. Have the base of artificial intelligence, and you can start the problem from here. You take the small problems, but what types of problem you will take? This is also one challenge because the students are new. So what types of problem you take up as a final year project? So first of all, you have to see your institution, how your institution is facing various problems regarding the library, regarding the energy management in your institute, regarding gardening. So many things are in the institute. You can take the small projects from there. Regarding the attendance, regarding the sending the message to the parents, like so many PT assignment you can have, you can use the artificial intelligence. So from here, the concept of artificial intelligence, the base of artificial intelligence, you can make. So this is the one my suggestion. Second thing I want that students generally work on the software. Yes, but final work is always done using the hardware. In our time, the whole project was based on the hardware, whole project. But in that case, the flexibility and reliability was very limited. So as programming has been developed, scientists or researcher use this software or programming or with the collaboration with the hardware also. So the concept of hybrid technology came. So when hybrid technology came, the most of the control, sensing the things has been come through the software, and controlling activities has been done through the software. So in this way, year by year, we focus on the software, and the hardware has been removed. But finally, students today are not interested in the hardware. So students should also involve themselves in the hardware. One more thing that you have to take the programs from where you can take the what types of work you want to do. So you have to see the institution first. Then you have to see district where you are residing. What are the problems of the districts? So first of all, you have to identify the problems. When will you identify the problems? Then you will go for the solutions. Then you have to think about the state in which you are living. What are the specific problems of the states? What are the specific problems of the code? What are the specific problems of the healthcare systems? So many problems will be comes in mind. So first of all, the first point will be that you have to analyze the problems either of the institute or the district level, state level, and finally on the nation basis, what you can do. Also, India has already signed 17 number of sustainable development goals. You can take up the problems from there also. What are the 17 goals has been decided by UNO, and India will have to fulfill by 2030, not 2030. If you are taking these goals in the life, you can sustain our development. So you have to think the direction. In this way, you can take up the problems and then you can go for the solutions. But we were talking about the with Sandeep Negi ji, he was telling that the young minds, they are very intelligent. We can't think, we can't do, but young minds are can do. Modi ji always tells that India is the country of the young people. Really, more than 65, 44, 64, 65% population over here. And more than 50% are at the age of the 25. So really, this is a big strength. When we take the examples of China, one more suggestion I would like to give, that reverse engineering also opt. If you find somebody that somebody using the artificial intelligence, so you start doing the reverse engineering. China had did in the same way. He purchased some items from the America. The year-old model of the China is America basically. He purchased some items from the equipments from the America. He enrolled all these things, see what is happening over here. Then they made their own base. And finally, then they have prepared their base. And now the whole world is having the equipments of the China. So in this way, we can proceed also. First of all, we have to make the base. So definitely, we have to go for that also. But it is not ethical, that is there. But we have to start. Definitely, it will help you. Then you can think, first of all, you have to make the foundation. Then you can think about your problems. So in this way, you can take up the problems. With these words, I think you can go for the sessions. And today, the final, just listening of the session regarding the AI deep learning is not sufficient. As it is always told, beginning well begin half done. It means you have to start. You do not think that you will start day after tomorrow or tomorrow we will start. You have to start immediately. So this is my suggestions, and the program, the way the university has organized, this is really very appreciable. This will be very much fruitful, and it will be really good lesson for the newcomers, yeah, new students who have just was not aware about the artificial intelligence. Definitely, this will be very much beneficial. With these words, once again, I welcome everybody and give the thanks to everybody giving me opportunity to share some my words. Thank you, Nikesh ji.
सर बहुत बहुत धन्यवाद। सर ने जिस तरीके से तकनीकी के हर क्षेत्र को छुआ और इंटरलिंक करके हमें समझाया, या आइकन पूरे परिवार को समझाया, यूनिवर्सिटी के जो बाकी स्टूडेंट्स हैं उनको समझाया, तो इसी प्रकार से सर के आगे भी मार्गदर्शन के लिए हम सर को बार बार निमंत्रण इस चैनल पर भी देंगे, आइकन सीरीज में देंगे। और ये जो डिफरेंट यूनिवर्सिटीज से जो स्टूडेंट्स हमारे साथ इंटरलिंक हो रहे, कनेक्ट हो रहे सर, तो उनको भी क्योंकि मैंने कहा कि ये डेटा संग्रहण भी है और डेटा प्रसारण भी हम इसके माध्यम से कर रहे हैं सर। तो वो प्रसारण करने का मतलब ये होगा कि रिमोट लोकेशंस पर जो स्टूडेंट्स हैं उनको भी जो वर्ड्स यहाँ पर स्टोर हो रहे हैं उनको भी सीधा सीधा इससे फायदा मिलेगा, जो रिमोट लोकेशंस पर स्टूडेंट्स हैं। तो सर का एक दफे बहुत बहुत धन्यवाद। अब हम प्रेजेंटेशन के लिए सर स्टूडेंट्स को कॉल करेंगे। थैंक यू वेरी मच।
मैं तो रुका रह सकता हूँ, देख सकता हूँ प्रेजेंटेशन उनका।
क्यों नहीं सर, बिल्कुल बिल्कुल सर,
ठीक
आपका
है,
बहुत बहुत स्वागत है, बिल्कुल पूरी तरह
ठीक है, ठीक है, ओके ओके।
Thank you so much again, sir, for such an insightful and informative words you share about artificial intelligence and emerging technologies. Your knowledge and perspective you share about reverse engineering and taking problem from software development goals will undoubtedly inspire us to explore these field further and apply these concepts in our academic and professional journey. Once again, thank you so much, sir. Now, moving ahead with first presentation of today, AIKN session, I would like to invite Manaswin Shah, third year student from Birla Institute of Applied Sciences, Bhimtal, Nainital, on the topic Deep Learning and Machine Learning.
Hello, am I audible?
Yeah, you
Yes,
are.
yes.
Yes. So let me share my screen. One sec. Is my screen visible as well?
Yeah, it's visible.
Yeah.
Yeah. So, good evening, everyone. My name is Manaswin Shah, and I'm here representing Birla Institute of Applied Sciences, Bhimtal. And the topic that I have selected for today is machine learning and deep learning. Over the past few days, we've heard many presentations about artificial intelligence, machine learning, deep learning. And most of these technologies work very well when data flows with a specific structure. For example, if we have images, the images are arranged in a grid of pixels. Or we have text, which is arranged in a sequence of words. Audio is arranged in a sequence of sound samples. Because of these structures, models like CNN, which is convolutional neural networks, and RNNs, which is recurrent neural networks, have become very popular. But what happens when this data is not presented in neat rows, columns, or sequences? Think about social media, where users are connected to friends, or molecules, where atoms are connected with each other in complex ways. Okay, or internet itself, where billions of web pages are linked together. These systems are not grids or sequences, they're graphs. So today I'm going to be talking about a specific topic inside deep learning, which is graph neural networks, or as we call them, GNNs, which is a rapidly growing area of deep learning. So to understand why GNNs were created, let's first look at the limitations of traditional deep learning models. So as you can see here, traditional deep learning models are powerful, but they were designed for a very specific data structure. Let's start with CNNs. So CNNs assume fixed grid-like spatial structure that cannot model arbitrary connectivity. For example, here you see images, right? It is formed with a bunch of grids. And this is fixed in nature, right? And it requires parallel processing. Similarly, if we take RNNs, which is recurrent neural networks, it is a sequence of data, for example, text or audio. Okay, but these both, they have a limited platform. Okay, each pixel has a predictable neighbor. But imagine social media where one person has 50 friends or another person has 500 friends. So connections can be very complex in such a manner. Okay, so here as we see, a graph is formed. Okay, there is not a fixed grid. Okay, so this is where we use graph neural networks. So this gap that creates in which real world data and social network molecules, or maybe even knowledge graphs, is inherently non-Euclidean. So to address it, we use graph neural networks. So, to see how this works, we will first need to understand how a graph is made. For example, a web page. So, a web page can be connected to another web page. This web page could be connected to another one, and it could be connected back to the first one. Whereas in a sequence, one after the other, they are connected, but they're not connected within each other. This is what makes graph neural networks different. Okay. So, to understand how a graph structure works, we will need to understand what a graph is in its core component. And the main component of a graph is a node and an edge. The node represent entities, for example, users in a social network. And an edge is a connection between them. So basically, if we see the previous slide again, we can see that a graph has a bunch of nodes and connections between them. Then we have something called as an adjacency matrix, which is the foundation of many graphs. Think of it as a giant table where if a node is connected to other node, we represent it as one. And if a node is not connected, we represent it as zeros. So it has a graph has three things: the entities, the relationships, and the attribute of those entities. For example, an entity could be a student. Okay, so the relationship of student can be with a teacher, the relationship of student could be with a course, and the attributes of student could be roll number, student address, as such. So we see why traditional deep learning struggles with relational data. But the most interesting question here is how graph neural networks can actually learn from this. So now we will move on to the next slide, and this will explain the main concept behind how a graph neural network actually learns, which is called message passing. So the core mechanism of message passing is the surprising idea of basic intuitivity. For example, imagine a group of friends, they are discussing a topic, right? Each person has their own knowledge and they share this knowledge with each other. And as they share this knowledge, each person finds out more knowledgeable things. So, first thing is aggregate. For example, there is a node, it gathers in more information from its other nodes. Okay, it aggregates this information. Then, what it will do is it will one sec combine this information, it will combine all this information and then it will update itself, like how you talk to your friends, you find out about new things, then you update your own information, and then you repeat this process. This is known as message passing, and this is how you can understand how GNNs are so powerful, because they have the ability to learn through connections. Now that we have understand how information flows through a graph, let us look at some of the most important GNN architectures that researchers have developed. Over the years, many researchers have proposed different types of graph neural networks. Each architecture solves a different kind of problem. First, we have input graphs, we have graph convolution, there is nonlinearity, pooling, and then there is output. To understand the key architectural choices that we have, the first one is GCN, or Graph Convolutional Network. So I'll explain to you what convolution is basically. Convolution basically is a word that means if we have many options, right? If we have a lot of data and we use a filter again and again on the same data to get a singular summary. Think of it as like a funnel. Okay, so you filter out a lot of data, okay, and then you get a singular point of summary, that is convolution. So GCN is basically doing what? It is taking information from many nodes. Just say I showed you a graph in the beginning. It has a bunch of nodes. So it will take information from all those nodes and it will apply a filter again and again and get a singular summary out of it. The next thing is a graph sage. It is a next architecture. So when we have large graphs, okay, the main challenge it faces is scalability. Okay, because graphs can have millions or even billions of nodes, like internet, billions of people use it. So processing such a big graph at once becomes very expensive. So Graph Sage addresses this by sampling a subset of neighboring nodes rather than examining all of them. So it is only examining neighboring nodes. So this makes training very fast. This is also called inductive learning. The next thing that we have is GAT, which is attention mechanism that allows model to assign different importance weights. So for example, if you want to increase the importance of one neighbor, some neighbors can be more important, the other neighbor can be less important. So what this is doing is, this is putting more attention to some neighbors, which will make it more relevant. And the last architecture is GIN, or Graph Isomorphism Network. In simple terms, some graphs look very similar and can confuse the standard GNNs. Okay, so GIN, it helps to distinguish between these architectures. For example, one graph can be very similar to the other graph, but it can have some differences. But basic GNNs cannot understand those differences. To help with that, we use GINs. This is basically a representation of how GNNs is learning. See, GCN mein, it is doing convolution, it is filtering out. Graph Sage is learning from only a sampled area. GAT is assigning more importance to some nodes, and GIN is helping to distinguish. So what we are doing here is we are providing more options for GNNs to work with. How so now we know like how GNNs are, attracting so much attention because they have a wide range of applications. So let us start with like how it is used in real world. For example, recommendation systems. Okay, Platforms like Netflix, YouTube, or even Amazon, they can predict what their users will like next. How do they predict it? For example, you like something, you like a certain type of clothes. Okay, it has noted down your preferences. But another person also likes certain types of clothes, but he also likes something extra. So it will see that you both are, you both like the similar kind of things. So it will recommend similar things to both of you. This is how it is recommending things, and it is very, useful because it can analyze connections and uncover hidden preferences. Second application of this is fraud detection. Financial systems generate huge network of transactions, and fraudsters also operate in a lot, like a huge number. So they create very complex transaction patterns. So GNNs can analyze the entire network and allows the system to identify suspicious clusters or hidden fraud rings, which would be otherwise undetected. Okay, the other thing could be drug discovery. As I said in the beginning, also that nodes can be anything like molecules, and the connections between them could be the connections between the molecules. So, when atoms become nodes and chemical bond become the edges of a graph, then we can use graph neural networks to learn directly from these models. So, tasks which used to require a lot of research in the laboratory can now be accelerated significantly uses AI driven predictions. And finally is healthcare and genomics. So genes interact with proteins, and proteins influence diseases, and diseases affect patients. So these relationships can be represented with graphs. And graph neural networks help researchers discover hidden patterns with these biological networks. What makes all of these applications really remarkable is that the success that comes from understanding relationships. The individual data points are important, but the connection between them contains even more valuable information. And graph neural networks are specifically designed to learn from those connections. So, we have seen how graph neural networks work internally and how they are being applied today. However, no technology is perfect. Despite their impressive capabilities, GNNs also face several challenges, and we will look at that next. Um, Wait. But before we discuss like the challenges, let us discuss why GNNs are a paradigm shift. First, I'll tell you what a paradigm is. A paradigm is basically, you can call it like a pattern or a set of assumptions that limit you. So you can say things like, I'm stuck in a paradigm. That means you're stuck in a set of assumptions about yourself, which are limiting you from doing good things. Okay. So, why we call GNNs a paradigm shift? We are basically asking this question: why are GNNs causing the system that is present these days to change? Why is it, bursting through those limitations? So, the first thing is relational inductive bias. So the main strength that GNNs have is the fact that it can make, every AI model can make assumptions about data. For example, in CNNs, convolutional neural network, which process images, it assumes nearby pixels are related. Similarly, in RNNs, text and audio also, they assume that nearby tokens of sequence influence one another. Similarly, GNNs also assume that connected entities influence each other. For example, friends influence other friends, proteins influence other proteins, and customers influence other customers. So what we are saying is that using relations, we can induce a bias onto a group of or a cluster of nodes. The second thing is permutation invariance. So permutation means differences, right? So even if the nodes are, not ordered correctly, when using GNNs, the output will be given the output will be same no matter in what order you are arranging these nodes, which is the invariance aspect of it. Then there is the fact that it is scalable to very large graphs. For example, you can scale this using techniques such as graph sage, which I just explained, which uses clusters. it allows researchers to train models on extremely large networks. Without these techniques, graph learning would not be practical at a larger scale. And the final thing is the generalization aspect of it. The GNNs, they generalize data surprisingly well. In many cases, models trained on one graph also can be applied to many known graphs. So, despite these trends, GNNs are not perfect, and researchers continue to face several challenges when building a deeper, more powerful graph model. So, we will see the limitations that GNNs face. The first limitation is over smoothing. So I explained how graphs work. Okay, so it will take a bunch of nodes and it will, compare and contrast and share information. Like between friends, they are sharing information. But if you imagine two friends, we lock them in a room, and if we lock those two friends in a room, they will exchange information between themselves. Now, if they keep exchanging same information, then at some point, both of them will have, similar information. For example, if, you follow a particular political party and your friend also follows the similar political party, if you exchange ideas with them only, then at after some point, both of your ideas will merge. So the same challenge GNNs also face. So what this does is, if we keep, oversaturating GNNs, what it can cause is it can cause discriminative power beyond like 2 3 layers. The second problem that it faces is expressivity limits. Okay, so as I explained, some graphs could be very similar to each other. For example, you can show a person identical roads, but that person will not be able to distinguish between them, even if they have a little, difference. Same goes for GNNs also. If they don't have enough information, they might not be able to distinguish between two graphs. The third thing is memory and scalability. So if we have very large networks, for example internet, and we are applying GNN on it, it has billions of users, so it is going to eat through memory, and that is not, it is gonna require a lot of computational resources. And the final problem is dynamic graphs. Dynamic means something that is changing, like dynamic arrays. Okay, so the dynamic aspect of it is, same goes for internet again. Imagine you have a phone, right? You are a part of a graph, but someday your parents could buy a phone, they could also lose a phone, your friend buys a phone, then another friend buys a phone. So it is dynamic, which means it is constantly changing. And this also causes a computational problem because it might not be as efficient in the future. And this is a challenge that GNNs face. So now that we have discussed the challenges that we are facing right now, let us see where this is headed in the future and what the future of graph AI is. So the first direction is graph transformers. Transformer is basically a type, you can say RNN is also basically a transformer because it is using recurrent neural networks. A transformer, the main difference that a transformer has is, if we have n nodes, right? It will interact, every single node will interact with every single other node. So it will have almost the square of interactions. For example, if we have 1000 nodes and every node interacts with one another, that means we'll have 100,000, how many, wait, 1 million interactions. Okay, so a lot of interactions, that is very highly, it is going to require a lot of computational cost. So using graphs in that will help us achieve best of both world kind of scenario. Second is neurosymbolic GNNs, which is one problem that deep learning faces, is that it acts like a box. It produces answers, but it can not explain them. But graphs provide an ideal framework for integrating the approach of an AI system that not only learns patterns but also follows explicit rules and explains its decisions. The third scope is, graph foundation models. So we know foundation models like ChatGPT or Gemini or Claude. These are pre-trained on enormous amounts of data. So instead of training a separate model for every problem, we can use graph to learn from a universal graph representation and then be fine-tuned for specific tasks. And the final representation is just, artificial general intelligence and causal graphs. So causal graph means one situation causes another situation. So many researchers believe that intelligence is fundamentally about understanding relations and cause and effect rule. So graphs can naturally represent these relationships. What relationship is causing one another relationship, what effect this is causing. So graph might be able to overcome the foundations that currently hold back the present systems of AI and make a truly reasoning capable AI in the future. So after looking at the present future and the limitations of graph neural networks, let us conclude the most important takeaway that we have. So throughout this presentation, we discussed a very recurrent theme, which is the world is connected. Whether we look at social networks, transportation, biological processes, or scientific knowledge, everything exists within a network of relationships. Traditional deep learning models were designed for grids and sequences, but graph neural networks are designed for relationships. And this is what makes it unique. Data alone is valuable, but connections between data are often even more valuable. And graph neural networks give AI the ability to learn from those connections. And for that reason, graph neural networks are not just another machine learning model, they represent a step forward in a more relational or contextual and ultimately a more intelligent AI system. Thank you.
Thank you, Maniswin, for the presentation. That was truly informative and well presented. Now, proceeding ahead, I would like to call the next participant, Kanchan Sirwal, MTech student from Faculty of Technology. She will be presenting on the topic Energy Forecasting and Research Domain. Kanchan, please.
Hello, good evening, everyone.
Yes, audible.
Kanchan, you can share your screen now.
Is this visible?
Yeah, it is.
Yeah.
So, good evening, everyone. My name is Kanchan, and I am a student of MTech Power System first year in UT Dehradun. My topic is energy forecasting and research domain. So, in this presentation, we will study about the importance of energy forecasting, then discuss forecasting methods and challenges. After that, we will study application in smart grids and renewable energy systems. Now let us start with the introduction and importance of energy forecastings. So the topic is unlocking the power of energy forecastings. So in this topics, first we decide better with forecastings. So forecasting predicts future electricity demand and generations, and it helps in planning operations and maintenance. Second one in accelerated sustainabilities. Forecasting improves energy efficiency and it also helps integrated renewable energy like solar and wind. Third one is connected research to real impacts. Research model are used is actual power grid and industries. And fourth one is equip future leaders. It gives engineers and researchers a common understandings and this is also helps industries, policymakers and universities for work together. Next is why accurate energy forecasting is matter. So first one is keep supply dependable. Power generation is matched with demand, so reduce chance of blockage, blackout, and outage. Second one is cut operating costs, reduced fuel cost and unnecessary generations. And this is also improve unit commitment decisions. Third one is integrated more renewables. So in this, we have solar and wind powered dependent on weathers. So forecast predicts renewable energy variations. Next one is strength grids and decisions. This is improve voltage stability and congestion plannings. So we say that accurate forecasting improves reliability and reduce cost and support renewable generations and integrations. Next one is fundamentals and challenges. This is the key concepts in energy forecastings. First one is forecast what matters. So we say that load forecasting predicts electricity demand and price forecasting predicts electricity market price. Next one is match the time horizon. So in this, we divided short term and long term. In short term forecasting, this is able to minutes to days operations and balance. And long term forecasting used months to years for planning and investments. Next, model drivers and uncertainty. This is weather and calendar affect energy demanded. Next is major challenges facing forecastings. First one is data quality and access gaps. Missing or incorrect data reduce the accuracy of the systems. And system complexity. When power systems are large and integrated or interconnected, then unexpected events increase uncertainty into the systems. Next, EV and solar system and smart devices change load patterns quickly. So this is tough for energy forecastings. Next, we studies forecasting methods and technologies. Traditional forecasting methods. So in previous methods, we use statistical baselines that still matters. In this method, we use regression methods. This matters relations between temperature and electricity demand. Next one is time series tools for temperature, temporal or structures. We use ARIMA methods and ETS methods. Next one is exponential smoothing. And next one is foundation for modern hybrid forecastings. So in this, we use machine learning methods for energy forecastings. Emerging machine learning techniques. In this, we use AI forecast for learn complex patterns and use deep learning methods, big data patterns, and also adaptive forecastings. So we say machine learning improves forecasting accuracy and compared to the traditional methods. Next one is role of big data in energy research. So in this, with the help of smart meter, we can generate large amount of real-time data analysis and better features. So we say data can be analyzed by location, consumer types, and users behaviors. But the challenges in this like privacy, cybersecurity, and missing data issues. So we can say big data helps improve forecasting precision and also decision makings. Next one is application in energy systems. So renewable energy forecastings, we can forecast solar forecastings. Solar is dependence on sunlight and cloud conditions. Also wind forecastings. This is depend on wind speed and directions. We use hybrid models like solar plus wind, solar plus hydro models, and also grid impacts. Renewable forecasting is essential because solar and wind power are variables in nature. Next one is smart grids and forecasting synergies. So in this, we use real-time visibility. So smart sensor continuously monitor the grid. Next one is demand response. Consumer shifts using during peak demand periods. This is very reliable in natures and helps avoid congestions and outages. Smart grids and forecasting work together to create efficient and intelligent energy systems. Next one is energy storage and forecastings. So in this, we can charge during low demand. When the demand is low, we can charge our batteries, store energy. And during peak demand hour, we can store supply during high demand. Next one is optimize battery health and cost. Forecasting helps manage chargings and cycles. Next, reduce waste and enable higher renewable patterns. When extra solar and wind energy can be stored instead of waste. So forecasting improve better management and renewable energy utilizations. Next is policy, case study and research. Forecast save policy. Government use forecasts for energy plannings and accurate standards. Forecasting models are evaluated using MAE, RMSE and MAPE methods. Also, electricity markets help in this. This is help decide energy price and market operations. Policies ensure reliable, transparent, and efficient forecasting systems. So the forecasting will be easy. Next is case studies for real world applications. So in this we use proven projects, day ahead forecastings, and improve dispatch plannings. Renewable forecasting like wind and solar forecast for reduced congestions. Next is industry's lessons for combining AI and traditional methods for giving best performance. Next is student research contributions for researchers compare models using performance of renewable energies. So real world project prove that forecasting improves efficiency and renewable integrations. Next is research frontiers and opportunities. So in this, we use interdisciplinary research, AI and IoT methods, climate change adaptations, and open data collaborations. Future research focuses on intelligence, resilience, and climate aware systems. Next is skills, collaborations, and future outlooks. So, for future predictions of forecastings, we have to learn about data analytics and modelings, programming and machine learnings using Python and machine learning methods, systematic thinkings, understanding the complete energy systems, and also have a good communication skills for explaining forecast and result clearly. Next is continuous learning mindset for learning new technologies and continuously. Future energy engineers, both technical and communication skills also. Collaboration between academic and industries. So in this, we can use industry collaborations for universities and companies for work or join any projects. Next is student training like internships and capstone projects for improved practical knowledge. Research is also converted into real world applications. Innovation like any pilot projects improve forecasting systems. So we can say collaboration help bridge the gap between theory and practical implementations. Global trends in energy forecastings. This slide explains worldwide trends like international collaborations, emerging markets, global data sharing and standards, and sustainable development goals. So energy forecasting is becoming a global research and development priority. Future direction and innovations. Next generation forecasting like AI model combine weather, load, and price data. Quantum optimizations. Future technologies for faster energies and optimizations. Personalized energy management like homes and EVs will automatically optimize energy uses. So the future of forecasting will be smarter, faster, and more autonomous. Next is key takeaways and call to actions. So the conclusion of this presentation is the energy forecasting is essential for reliable and sustainable power systems. AI, IoT, machine learning, smart grids, and big data. This is also transforming forecasting technologies. Future success depends on collaboration between academic and industries and governments. Accurate forecasting will also help improve reliability, reduce cost, and increase renewable energy systems. Thank you.
Thank you, Kanchan, for that informative presentation. If somebody have question from the presentees of today, so they can ask. So I think nobody have questions about the today's presentation. And now, proceeding ahead, I would like to invite Dr. Sandeep Negi sir for vote of thanks.
अ, सर्वप्रथम मैं आदरणीय प्रोफेसर वीके सिंह सर को बहुत बहुत धन्यवाद दूंगा कि उन्होंने मॉडर्न साइंस और तकनीकी के इतने एरियाज को इंटरलिंक करके आइकन को अनुग्रहित किया। आपका मार्गदर्शन हमें लगातार मिलता रहेगा सर। ऐसी आइकन फैमिली और यूनिवर्सिटी और पूरे सिस्टम को आशा है। आपका बहुत बहुत धन्यवाद सर। आज के जो प्रेजेंटर्स हैं, मनस्विन शाह, बहुत ही शानदार जो इनका प्रेजेंटेशन रहा बिरला इंस्टीट्यूट ऑफ टेक्नोलॉजी, बिरला इंस्टीट्यूट भीमताल से। और साथ में कंचन सिरस्वाल का अभी अभी आप लोगों ने प्रेजेंटेशन देखा, तो इन दोनों बच्चों का जो प्रेजेंटेशन है वो अपने आप में बेहतरीन रहा। तो इन दोनों के लिए अ, मैं शुभकामनाएं अभी से प्रेषित करूंगा। और आइकन फैमिली में इन प्रेजेंटेशंस को देने के लिए आप दोनों का बहुत बहुत धन्यवाद। प्रोफेसर अमित वर्मा सर और प्रोफेसर संतोष मिश्रा सर भी हमारे साथ जुड़े हुए थे और लगातार नॉलेज शेयरिंग के इस प्लेटफॉर्म पर हमारे साथ बने हुए रहते हैं। तो आप दोनों प्रोफेसर्स का भी बहुत बहुत धन्यवाद। बाकी जो स्टूडेंट्स हमारे साथ यूटीयू के हैं या ग्राफिकल यूनिवर्सिटी से स्टूडेंट्स जुड़ते हैं, उत्तरांचल यूनिवर्सिटी से स्टूडेंट जुड़ते हैं, उसके अलावा एचएनबी गढ़वाल यूनिवर्सिटी से भी स्टूडेंट्स अभी अभी जुड़े हुए थे। तो आप सभी का भी बहुत बहुत धन्यवाद। यहाँ तक कि आईआईटी भिलाई से हमारे साथ स्टूडेंट जुड़े थे छायांक करके। तो या वहाँ से स्टूडेंट्स का इस प्रकार से जुड़ना अ, ये दिख दर्शाता है कि हम सही जा रहे हैं। तो उन स्टूडेंट्स के लिए ये प्लेटफॉर्म और रिमोट लोकेशंस के भी स्टूडेंट्स, इवन जो विद्या मंदिर के स्टूडेंट्स भी यहाँ जुड़े थे, तो उनके द्वारा भी प्रेजेंटेशंस दिए गए। तो ये सारे स्टूडेंट्स एक टाइप से इस प्लेटफॉर्म को पा रहे हैं और अपना प्रेजेंटेशन दे करके एक मार्ग अपने लिए ही प्रशस्त कर रहे हैं। और उन स्टूडेंट्स को मैं बहुत बहुत धन्यवाद दूंगा। वीके सिंह सर को एक दफे और बहुत बहुत धन्यवाद। आगे भी हम सीरीज सर लगातार बने रहेंगे। सभी लोगों को एक बार और धन्यवाद। थैंक यू।
Thank you.
So, as we approach to the conclusion of today's session, I would like to inform everyone that next session of AIKN's series would be conducted next month, and detailed schedule and the topic will be announced soon. So, stay connected. Once again, thank you everyone for enthusiastic participation. Have a wonderful evening ahead. Thank you, everyone.
थैंक यू।